All right, good morning. This question is from fluids. Which gets used for this is the Bernoulli principle. Okay, and if you read this question, you have 2 points. I'll just mark them. So one point is the inlet, and then you have an outlet. Okay, the velocity of fluid, which is water, at the inlet is given to be 0.40, and the velocity at the outlet is given to be 9.5 meter per second. Okay, the inlet is at a height of 180 meters below the intake. Okay, so this difference is 180 meters. This is your inlet, this is your outlet. The difference between the heights is 180 meters, right? All right, so the question is, and the cross-sectional area has also been given. Okay, so the cross-sectional area here is 0.74 meters squared. Let us see how we will use this. You have to find the pressure difference between the inlet and outlet, which means if the pressure is, P inlet minus P outlet. Okay, this is what you need to find out. Now, if you notice this question, and I say Bernoulli, the way you need to apply this is this particular one. P inlet. Okay, this is the pressure head. Then let's apply the potential head. Rho G H inlet plus the kinetic energy head, which is because of the motion of the fluid, half rho V inlet square is equal to P outlet plus rho, this is density, gravity, H outlet. H outlet is 0, by the way. Okay, so this is at ground level, so I'm going to put 0 here anyway. So plus half rho V outlet square, right? So we know the velocity here. V outlet is known to us. V inlet also we noticed is known to us, right? So P inlet plus rho G H inlet minus H outlet. Okay, so I have brought this to the other side, is equal to half rho V naught square minus half rho V inlet square. Okay, so this is your P inlet, and what I'm going to do is, let me just keep P outlet here for the time being. So P inlet minus P outlet plus this is 0, right? Outlet is at 0. So H inlet is how much? Rho G multiplied by 180 is equal to half rho. What is the velocity at outlet? 9.5 whole square. And we have already taken this to the other side. Minus half rho inlet, the velocity is 0.4 square, right? This is it. Now, if you use this, you can say P inlet minus P outlet is equal to half 9.5 whole square minus half rho 0.4 square minus rho G into 180. Let's start putting the values, and I'm going to put the value of rho here. So rho is common in all of them. Okay, so that is 1000, and the density of water is 1000. So 9.5 square minus 0.4 square minus 180. Don't worry about the sign, okay, because negative sign doesn't mean anything. It just means the pressure or at the inlet side. Okay, maybe we will talk about the sign. Okay, so this is 9.5, roughly around 95 multiplied by 95, right? This is what you need to do. 5s are 25, 47, 9 5s are 45, 9 9s are 81, 85, 5 12, 90.25. So this is 90.25 minus 0.16 minus 180. Okay, so this is P input minus P output. Okay, if you notice, the answer you probably will get is negative, which means what it shows is that P inlet is less than, if you get a negative answer, right, you can calculate this very easily, you'll get a negative answer. P inlet minus P outlet is coming out to be less than 0, which means P inlet is less than P outlet, or you can say the P outlet is greater than the P inlet. This is the only significance you need to understand. Okay, so if you have to do these questions, just remember that a direct way to solve the problems which are pertaining to pressure is use this equation. This is called as the energy form of the energy form, as in energy per unit volume, because if you see energy of the fluid, the energy of the fluid per unit volume, so this will become, new meter cube. So energy is given by force into displacement divided by meter cube. If you cancel this, you will get Newton per meter square, right? So Newton per meter square is pressure. Okay, pressure. So you can see this is pressure in terms of unit. The exact cause of pressure is different. This is because of the potential, the height. This is because of the velocity. So this is also known as velocity head, the pressure head, the potential head. So these are the names given to these expressions, and it's a constant. This is what it says. If you're studying Bernoulli, what you will find is, something called as a streamline. Okay, so if you have a streamline motion, okay, and the fluid is moving in a streamline, then the energy contained by the fluid at any point is given by the sum of three elements which I just mentioned: the pressure head, the velocity head, and the potential head. So if you calculate at A and then calculate it at B, right, it will remain the same. Obviously, there are terms and conditions for Bernoulli to be followed. The liquid has to be incompressible, ideal liquid, stuff like that. You can read what are the conditions for a liquid to exhibit streamline behavior, right? And what are the conditions that it will adhere to the Bernoulli principle. But if you look at this into this numerical, if you know the pressure, the velocity head, and the potential head, the sum of these three has to be a constant. Okay, a constant. And this is what I did at the inlet and the outlet. So at the inlet and the outlet, you can apply this. Okay, so this is your inlet and that's your outlet. I hope this helps. Please go through my playlist pertaining to the Bernoulli. You will find some excellent numericals and explanations on Bernoulli theorem. It's a very important theorem. You can expect one or two questions in AP physics, SAT physics, or if you're in India or Turkey, or you're in United States, you're in Pakistan, you are in any country. And recently, I think what I saw was one of the country which got added was Bangladesh. Okay, and so thank you very much, Bangladesh, for watching my videos. And of course, I can't forget to thank Philippines. Philippines is watching this channel, and thank you very much, Philippines, for that. So wait for my next video and revise the Bernoulli theorem from my playlist. Thank you very much.